NASA is preparing for a journey back to the moon, and after that, we're setting our sights on Mars. To get there, we need tons of rocket power coming from our Space Launch System.
When it comes to how much power this thing can push out, this thing is massive.
It's going to be mesmerizing to stand next to this massive vehicle. The immensity of it, knowing that this thing is going to be propelling a rocket into space and around the moon.
Hang on, it's probably best to start back at the beginning. It all started in Promontory, Utah, where Northrop Grumman manufactured each of the segments that make up the rocket's boosters. After a 10-day cross-country journey, the booster segments were delivered to Kennedy Space Center's Rotation, Processing, and Surge Facility, or RPSF. If this all sounds familiar, that's because it's the same facility that was used to process shuttle booster segments, which all came from Utah. Then they're ready to go to the iconic Vehicle Assembly Building, or VAB, where the rest of the motor segments are assembled and stacked on top of the mobile launcher.
So the one thing about this vehicle, of course, it's produced all across the country. Components all come here. They may be built around the country, but they all come together right here in the Vehicle Assembly Building.
Our SLS rocket will generate 8.8 million pounds of thrust to break through Earth's gravitational pull. That's more power than the Space Shuttle and the Saturn V rocket used. Teams with NASA's Exploration Ground Systems are responsible for assembling the boosters that will house the majority of that power. The twin solid rocket boosters, made up of 10 total motor segments, will stand nearly 17 stories when fully stacked. First, teams will inspect and prep the hardware. Next, they're ready to start stacking the segments, a process that takes time, patience, and a steady hand.
Once we have everything done in High Bay 4, we pick up the segment with the 325 crane, pick it up over the 16th floor crossover to where
that we need for Artemis 1 processing. And we've just been waiting a long time for this part of the vehicle to arrive so that we can get going on the next steps of our stacking operations.
Standing an impressive 212 feet tall and weighing a whopping 188,000 pounds, the core stage came all the way from Stennis Space Center in Mississippi. The core stage went through round after round of rigorous testing, including what's called its Green Run series, truly putting its performance to the test. The series involved 8 rounds that looked at systems individually before culminating in pure power. With over 700,000 gallons of propellant flowing through the core stage, and its RS-25 engines firing for 8 minutes straight, the successful final test resulted in some big emotions from the team.
We cried, we laughed, and we cheered because it was so emotional to see, the years of culmination coming through.
And that victory did not come without overcoming a few challenges, proving why at NASA we test as frequently and as hard as we do.
And we got to shut down. All personnel.
So we actually did a 1-minute test on the first hot fire test. And then we learned a lot from that. We understood the vehicle more, we made a few changes, and then we got back into our second hot fire test.
There was a lot of joy and workmanship and ownership of being able to work that process and be able to get it done. When we went for the second hot fire, and we went for the 500 seconds, that was just pure exhilaration.
VAB, where it was lifted by a crane and placed in between the twin solid rocket boosters. Serving as the backbone of the rocket, the core stage will provide more than 2 million pounds of thrust to help send the Orion spacecraft on its trip around the moon.
Essentially, we have these 2 massive cranes that are located inside of the VAB, where we go ahead and we pick 2 points at the end of the core stage, one on the back portion of it and on the front portion of it. We lift it up to the point where we're able to transition it from a horizontal position over into a vertical position, and then essentially bring it way up to the top of the vehicle assembly building and cross it over into high bay 3, in which we ensure that we don't damage any part of the vehicle as it's incoming into its position.
NASA's largest rocket stage, now fully integrated with the twin boosters, is ready to get Orion off the Earth. But it will take one more critical component to give the capsule that extra push it needs to journey tens of thousands of miles beyond the moon. With just a single RL-10 engine, the Interim Cryogenic Propulsion Stage, or ICPS, will provide over 20,000 pounds of thrust to send Orion on the ride of a lifetime. To connect the ICPS with the rocket stack, teams next added the launch vehicle stage adapter to the core stage, followed by the ICPS.
The ICPS is the Interim Cryogenic Propulsion Stage, and essentially it's somewhat of the upper stage of the entire SLS vehicle. And what that will do is propel the Orion capsule along with its service module over to its destination, which at this point in time will be the moon.
But before the spacecraft can be attached to the rocket, teams will conduct a series of tests to ensure all of SLS's components communicate properly with one another, plus the ground systems equipment, the launch control systems, and its software. Adding to the challenge, those methods for testing have changed significantly since the days of the Apollo program. Initially built in the 1960s to house assembly of the Saturn V, the VAB has undergone some major modifications to support several different kinds of rockets and spacecraft, whether they're going into low Earth orbit or venturing to deep space.
This high bay was Shuttle Heritage. Before that, it was Apollo Heritage. So there's upgrades that are still occurring today to include upgrades that will support Artemis 2 and Artemis 3.
When SLS blasts off from Kennedy's launch pad,
space flight and exploration.
Artemis is going to be a major part of history. It most definitely is going to, this world needs that.
I'm so excited. It's going to be a lot of work ahead of us, but Artemis 1 is going to surprise everybody.